Hello, all. Welcome to another episode of AWS Show and Tell. I am Anil Nadiminti joining from New Jersey today, and joining along with me is Bharati. In today's episode, we're going to go into some details. We're going to do a deep dive on why we need policies for, on agentic evaluations and how we can get there, right? So, but before we go into the details, let's also do some introductions. Bharati, you want to introduce yourself?
Hi, yeah, thanks, Anna. I'm so happy to be here. I'm Bharti. I'm a Gen AI data scientist in AWS. I've been specializing in responsible AI and large language models for various agentic applications across enterprises. I'm really happy to be here and talk about building new governance safeguards using policy in Amazon Bedrock AgentCore.
Excellent. Bharati, where are you joining from today?
Oh, I am from Seattle, and believe it or not, it's actually sunny today. So I guess it's a wonderful day.
Excellent. Right. So we are actually under a heap of snow here in New Jersey. So digging our way outside. Um, but that's us here. Let us know in the chat where you folks are joining from, and let's take this away. Right. So in this deep dive series, we've already discussed how to bring your POCs into production. We've discussed about the frameworks, strands frameworks, also being able to host your agents in runtime, agent core runtime, making the services like agent core memory available to store your conversational history, extract summaries out of conversations. Also shown you how you can create MCPs using agent core MCP gateway. But in today's conversation, we want to focus more on how you can also enforce certain actions with your agentic invocations, right? Because agents are doing this tool calling, and you want to ensure that there are safeguards in place and enforcement actions that you can also take. So Bharati is going to dive deep today to understand and help you understand more about this, right? So Bharati, what's all of this about this policy and the policy engine, right? So can you talk about that?
Yeah, I know you already set a wonderful stage to be able to talk about this, right? So we have AI agents which are proliferous across enterprises, and we've all been experimenting with it. And typically, these agents are also calling hundreds of tools on behalf of you, a real user, or even other systems. And the cost of getting access and authorization wrong, whether it's through overly permissive access or slow decisions or hallucinations or even brittle ad hoc checks, all of this becomes unacceptable. So the focus is on how you can bring in centralized and deterministic safeguards on controlling what agents can do when they're connected to all these tools like MCP Savas and other agents, for instance. So we want to basically have something that would align the security, architecture, and performance and be able to design and prove that a POC can meet not just your cost and latency goals, but it should not sacrifice the control you want to have on your agent.
That's great, right? So, for example, if we want to have agents that are doing some operations on behalf of us, right? So, and they are making those tool calls, you want to have those safeguards in place and ensure that they can only do certain operations in a certain way, right? So, we're going to dive deep into that. At this point, we are just setting the stage here for you folks to get you to know more about this. Now, Bharati, let's take an example here and maybe a use case example on what would be most applicable, where this would be most applicable.
Mhm. So think about maybe enterprise application like a healthcare agent, for instance, and it's connected. Perhaps it's a very simple agent. It can just help you book, for example, appointments with your doctor, right?
Mhm.
And now, when I'm trying to access this agent, first I'm going to authenticate myself that this is who I am. This is probably what on the back end they're going to authenticate myself as exactly what patient I am with some ID and so on. Now, I should have access to modify appointments that have been only made for myself. I should not have access to any systems which have other patient data or
Mhm.
the ability to modify someone else's appointments. However, when we have these kind of agents which are connected to these wide variety of tools, they without the right control and boundaries, they can start taking unsafe actions. Now, it can show up in a couple of ways, right?
Yeah.
Take unpredictable runtime behavior, for instance. So even if the agents are very carefully designed, now the decisions they take at runtime actually depend on the evolving and the tool responses. So the LLM, the large language model underlying the agent, is actively listening to the information it gets about the user, as well as what responses it's getting back from the tools themselves, which means there's also a variety of possible attacks for adversaries in terms of the inputs they can manipulate, which get to the LLM itself. Now,
Right.
this is not something you can fully predict ahead of time.
And maybe if we take an example of maybe a use case where there is monetary action involved, like a refund policies, right? So the agent should be able to do refunds until maybe $25 or $50, but then after that, you need to enforce some kind of policy action that the agent should not be able to do refunds, right? So maybe to prevent any fraud or any of those actions from happening, or maybe you need a human in the loop to look at this more carefully to allow that action to take place.
That is a great example, right? For example, they shouldn't like LLMs can misinterpret business rules. So you can even in the system prompt to a large language model, tell it that do not process refunds above a certain amount because this could violate your internal policy. Like approving a transaction that can meet the user's criteria, but it's not the business policy, right? So your agent, you can instruct in the system prompt, tell the agent, be helpful to your users. And in the same system prompt, you can tell it, do not refund above, I don't know, $5,000. Now, which part of the instruction in the system prompt is your LLM going to listen to? Is it going to be the be helpful part, which in this case, the user is actually asking for a refund. So if it's being helpful, it should actually process all refunds, right?
Mhm.
So this is also a good reason why you shouldn't put these kind of business rules, internal policies into a system prompt itself, because the LLM, you don't want to give a choice to the LLM whether to obey this rule or not.
Exactly, right. So exactly, and then people, again, it could be a misinterpreted action, or maybe bad actors that are trying to play around the system prompt exploit that, right? So you need to have more enforcement actions in control, and that's why we are talking about uh, this new offering here. So let's talk about that, right? So agent policy in agent core.
Yeah, absolutely. So the TLDR really is, how do we give agents the freedom to act without letting them cross these boundaries that you didn't intend for them, right?
Hmm.
So this is our whole premise and vision for policy in Amazon Bedrock AgentCore. We want to help enforce deterministic boundaries over the actions that agents can take. Let's actually look at this with a deeper example of understand agents from scratch, how
Hmm.
they're typically behaving, and then how policy is going to help you with it. Now, let's just start with this blind agent. It can be any particular use case. Now, in this case, your agent is very flexible because of this underlying large language model powering its reasoning. It's highly dynamic. It adapts to the tool responses and user queries and gives valid responses. And the behavior is defined by the code, which is typically procedural code and declarative prompts, like your system prompt, the user prompt, the tool that is attached to. But it's not just limited to this code, it's also dynamically changing its behavior based on the information returned by the environment, which could be the user giving information or even the tools. So for our purposes, let's just say this agent code isn't actively adversarial at all. It could be buggy, but
Hmm.
at the moment, it's not adversarial. However, the tool responses, the environment state, human interactions, all of this in turn could actually be controlled by adversaries. But for this case, let's just say we're starting with it could be buggy scenario, but not really actively adversarial. Now, it's connected to two tools you can see here. One, there's a reimbursement tool, and there's a calendar reading tool. Now, uh, in this pattern, we see all the interactions to these tools going through a gateway. So there's a single point of um, like a barrier before it can reach the tools. Now, even in this kind of common framework that we've been using for agents, security is hard for a couple of reasons. Now, first, we want them to be flexible and adaptable. So every constraint we start putting on the agents actually going to reduce the value of the agentic model. The so we don't want to put hard coded rules into the agent itself, because this is going to start limiting how it's going to behave with the user. We also already talked about how putting in rules in the system prompt is also not guaranteed that the agent will follow them, right?
Hmm.
So this is the primary reason security is so hard with agents, because they're running on LLMs, which are probabilistic machines. The second one is that an LLM itself, which is the underlying primitive of an agent, does not have a very hard separation between what an instruction is and what incidental data or incidental text is. Now, what I mean by that is the LLM doesn't have a very robust mechanism for differentiating between a command and data. So I could have send a command saying send a reimbursement to Bob, for example. But on my calendar, which it has access to, I can also have a reminder to myself as a calendar block saying reimburse Bob on this particular date, right?
Yeah,
Now
the
the
LLM sees everything as a context, right? So it's all text in the context of the LLM, or maybe tokens at that point.
Yeah, exactly. So all of this, both the command and the data, is flowing through the same context window with no architectural boundary. So it's not distinguishing between this is a command and this is data. So this is why I'm going to, if I say reimburse Bob, should it call the reimbursement tool or should it look at the calendar tool and retrieve this piece of data, right? So it's
Right.
not very clear to the LLM. Now, so when we start talking about safety, now what I mean is we want to start constraining the set of things the agent can do. Now, think of it as a box, right? Every interaction between the agent and the outside world has to pass through the walls of this box. And every time an interaction is happening through the walls of this box, we're going to enforce policy, which is going to be very deterministically applied. This is how we guarantee absolute safety in when your agent is interacting with tools.
So this is an important point, right? Because agents are non-deterministic by nature because of the LLMs that are under the hood, and we are trying to add a deterministic approach here so that we can control the actions on every interaction with the agent that the agent is having with the tools that are the tool calling that's happening here.
So compare this again with one of those examples we've been talking about, like the reimbursement tool. So let's say your internal company policy is your agent can handle reimbursements if it is up to $1,000, and everything
Mhm.
above this has to go to a customer rep. Now, if we just gave this as a system prompt, now your agent may or may not listen to it, so it's non-deterministic. But by enforcing it as a policy, it's always applied.
Now,
So if you're
why can't we do this in the tool itself, right? So again, we could write the logic in the tool reimbursement tool that do not process again refunds over $1,000.
Mhm.
Why do we have to use the policy in this case?
You can actually absolutely achieve the same goal of constraining the tool call in the agent code itself. You can just put these business rules into your tools, but this approach has a couple of downsides. So first, it would depend on the implementation of that code not being bypassed by the agent under any circumstance, right? So if you have any fixed function imperative wrapper around this calendar reading tool or the reimbursement tool, now it can be bypassed. So if the moment you start putting in these rules, you're also limiting the flexibility of the agent, and there's a very subtle burden on the developer as well. So one, when the dev now all this business logic and internal policies are being maintained in the tool code itself. So the imperative is now on the developer instead of the governance persona or the auditor persona. And when we start looking at the whole application and thinking if we have the right policies encoded, now you're going to be reading a much larger code base just to understand what policies have been incorporated, right? You don't
Mhm.
want to always do a full code reasoning, which can be a very tough task on large code bases.
Right, that's a very important point, right? Because as you make those changes within the code base, number one is it's a change within the code base. It could still be a configuration within the code base, but you want it to be auditable. You want to probably look at, hey, what if I change this instead of $1,000, if I make it $1,500, right? So if you want to keep playing with it and maybe not enforce it right away, but being able to uh, understand what the enforcement actions could be, right? I think so that makes sense.
And always with agents, we're also thinking about a different persona who actually wants to come in and check what your agent is doing in production, like a security team or an auditing team, where they want to come and see what the policies are correct. And if it's embedded in your code base, one, managing it for the developers is also difficult, but then also even showing what internal policies are encoded becomes much harder.
Mhm.
So what we're doing with policies, we're moving this out of the agent. And by doing this, we get to crisply say that policy gets enforced no matter what the agent does, no matter how the agent is abused. So we're coming back to this adversarial scenarios that could happen. And also no matter what bugs could exist in the agent code. There could be conflicting rules within the tools itself, which have not been managed correctly. But despite all of this, by abstracting policy outside of it, we're able to make agents safer and also much faster to develop because you have a more manageable code base, and also you don't have to disrupt production traffic to bring in policies, which I can also show you when we get into the demo.
That's great. Yeah. So we are going to look at this live in action in a little bit. Bharati has some demos ready to show you, but yeah, let's keep talking through this, right? So now we have policy that's looking at every single request that's flowing in there, and we have some enforcement actions that we could take.
Another key aspect of just safety and security about your agents is one, controlling what can happen, which is what when we have session isolation within your agents itself. For example, what AgentCore runtime offers, complete session isolation. The second one is controlling what the agents can do, which is what policy helps you with. So it controls all the interactions happening between the agent and the outside world. And finally, we also want to know what actually happened. So this is where observability comes in. So we observability and policy are tightly integrated in the agent core set of primitives. And we're tracing every agent decision and tool invocation and giving complete visibility to the developer into the agent behavior.
Hmm.
So you will be able to see when it's calling through the gateway, what tool it invoked, which policy applied to it, and what the outcome was it as well. So this basically closes the loop. We are going to keep things contained in the agent run session or runtime, and keep them isolated. Then policy keeps the actions governed, and observability keeps them accountable.
Excellent. S-
So yeah, let's look at how policy as a primitive in Agent Core behaves with everything else.
yeah, let's
So
dive deep into this, right? So share us more about the details here.
um, so irrespective of where your agent is hosted, the primary point of enforcement for policy is Agent Core Gateway. So if gateway is configured as your typical pattern where all the tools are added as targets and your agent is interacting through the gateway, now you will be able to attach a policy engine to it. So a policy engine is nothing but something that'll hold all your policies. And once you attach a policy engine and have policies in it, it's going to actively monitor all the traffic flowing into your gateway, trying to access the tools. What this does is it gives you a unified protection through deterministic policy enforcement. So you're able to intercept all the agent tool interactions and
Hmm.
start governing them using your policies. And behind the scenes, we're also optimizing for latency, which means we can give you low latency policy evaluations, which allows real-time decision making. The policies themselves, we're also going to look at how to author them. They do use a language called Cedar, which is our open source language for policy authorization. But you will also see how easy it is to author these directly in natural language and then have them converted into Cedar by the capability for you. Finally, I did say it also has integration with CloudWatch itself. So this gives you a very granular visibility into policy enforcement, also with showing you which policy IDs actually came into effect. So what do you say, Anil? Should we start looking at the demo
Yeah,
itself?
before we get into the demo, I know policy is something like a new primitive here for people to understand. Like, how long does it take to create a policy? Is it do you have to know a lot of coding? Can you do it from the console? Like, just maybe talk about that, right? So, you spoke about Cedar language. Maybe we want to understand a little bit more about that as well as we go into the flow, right? So, yeah.
Yeah, absolutely. So it is actually quite easy to just work on console if that's where you're comfortable. Be able to create a policy engine, attach this to a gateway, start authoring your policies directly in natural language. So there is no barrier to knowing Cedar or even coding to get into this. So this makes it actually very easy for also different personas other than just the data scientists and machine learning engineers to go in and start authoring policies for their agents itself,
So product
especially when
managers could go in there and then, enforce. I mean, type the rules like in natural language, and then could they see that in real time onto how it performs?
yeah, absolutely. Let's actually do just that, right? Let's go into the console. Can you confirm you see
Yep,
this?
we can see the screen.
Okay, perfect. So I'm inside my AWS account and I'm in the Amazon Bedrock AgentCore landing page. So once you're inside your console, you will actually see how we've integrated now policy already as one of the native resources in AgentCore. You can see on the build panel, there is policy. Now you have three easy steps, two to get started, one to start monitoring. Now, the first one is actually creating a policy engine. Now, this is what I talked about. A policy engine is a collection of policies. So this is the first step you want to do. The second one is the second step is actually now attaching this policy engine to an active gateway. So you could have had a different developer in a different team develop, for example, this agent, which is probably a customer support agent, like doing the refunds. And then I'm going in as a product manager and say, hey, my business rule is don't refund above $1,000. So I go and find out which gateway the developer has created, and I go and attach my policy engine to it.
So when you talk about that, Bharathi, now there could be maybe one policy or multiple policies, right? Because we could have like refund policy, we could have like another policy. Can we attach multiple policies to this gateway?
Yeah, absolutely. So in a policy engine, you can have up to 1,000 policies, and in an account, you can have right now 1,000 policy engines.
Yeah, these are
So
all
you
soft. I mean, these are all quotas that again you can evaluate. You can look at the quotas page to see if those can be modified. But for now, those are the numbers that are available, right? So, but the
yeah.
answer is that yes, you can attach
So
multiple
you can
policies.
you can attach several and multiple policies
Okay,
which you may or may not want to do. But like, long story short, business rules, your internal policies, these high risk applications where you have like these, edge cases where you say, under no circumstances should my agent do this, right? Now, these are the things you would typically put into policy to give you that, say, peace of mind that your agent is going to do the right things, even under adverse situations. So let's actually go ahead and create a policy engine and say, I'm doing this for my show and tell. Now, what we've done now is actually created an empty policy engine. So you can go and once I've created it, it's in the status of creating. It's not got any gateways attached to it, as you can see, and it also doesn't have any policies. So before we get into defining policies here, right, let's actually pick a very concrete use case, which makes it much easier to start talking about creating policies and authoring them. Is
right.
that okay?
Yeah, let's do that.
So let's
Yeah,
come
let's.
back to the use case and let's start with insurance use case. Now, what this typically is going to do is going to take care of insurance underwriting use case. So you have basically users who are going to go in here and create their insurance applications. But then the same agent is actually used by multiple different personas across the underwriting use case itself. So there could be an end user who's authenticating themselves and using the create application tool, for instance. But you can also have the underwriters themselves using logging into the agent with a different set of credentials and using the approval tool. So they're basically going in and looking at the insurance claims that have been created and approving them. You also have some risk analysts who can come in and look at the risk of the models by calling the appropriate tool. So my point is you can repurpose this agent to serve different users across the entire business case just by manipulating what kind of tools the agent is going to call based on who is using the agent. Does that make sense?
Yeah. Yeah.
So what is typically going to happen is, let's say I'm an end user, I'm going to send a prompt to my agent. Now, for the purpose of policy itself, you do not have to be hosting your agent on runtime. This is simply an example where I'm showing, let's say it's hosted, my agent is hosted, and it's calling the gateway where the tools are attached. So it's going to call it. The model is basically going to reason about the user query. Let's say I'm asking it, create an insurance application for me. I'm based in the US region in Seattle, and I want an insurance coverage amount of, let's say, um, 10 million, right? Let's shoot for the moon. So I'm going to try to create this, send this query to the agent. The LLM behind the scenes is trying to understand what is the right tool attached that will help serve this user query. Then it's going to understand, let me call the create application tool. So it's going to try to call this tool on the gateway. What is going to happen is when we start attaching this policy engine to the gateway, now before the tool is even invoked, the query or the request will be actively evaluated against a set of policies. So it's going to first check, is the user under the set of conditions actually allowed to call this tool, right? So we're going to, only if it is approved, only if the policy engine says, yes, you can call this tool, will this tool call even happen. And once it does, the result will be passed back to the agent, and the agent will communicate it back to the user.
So I want to
Now,
dive deep later on to understand how the user can be authenticated and how the tokens can be passed, and maybe talk about the identity itself, right? So maybe we'll
mhm,
park it for a little bit later, but yeah, please
mhm.
continue.
We will absolutely talk about identity, as well as when I show you the agent in runtime in my demo. Then we will also see how identity plays in, but we can also
Hmm.
address it definitely in depth. So let's say your policy actually denies this. Then what happens is your tool call will not even happen. So the response will simply be an error code that is sent back to the agent, and you can instruct your agent on what you want to tell the user. Let's say maybe you ask them to go to customer support, or maybe you ask them to first check the FAQ page. But like basically, the agent, is going to get an error code back saying it's been a policy violation, and then you can instruct your agent on how to handle it.
Hmm.
So with this use case in mind, first let's see gateways, right? We have this gateway set up already for us for the insurance underwriting use case. And we have three tools attached to it, which is this risk model tool that is for the analysts to look at the risk itself. If you go into it, we will see a schema for this. Now, attaching the schema to the target is really important. And the reason is there is a name for what this function is, as well as what the different tool parameters are, which is API classification and the data governance. Now, essentially what this means is if I want the agent to call this invoke risk model tool, it needs to pass two parameters to the model, to the tool itself, which is
Hmm.
an API classification, which can be public, internal, or restricted, or a data governance, which is a Boolean, so it can be true or false. Only if this is passed will the tool call even be successful. Um, we have two other tools attached, which is my application tool, which is allowing me to create applications as an end user. And to call this tool, we have to provide it an applicant region and a coverage amount. Now, the reason I'm calling this out as important is when we start authoring policies, I told you we have this natural language capability. But for the LLMs, which are basically understanding what policies to be created with a precise syntax,
Hmm.
it's actually pulling this schema from the gateway to understand what is the tool name, what are the tool parameters. So when I go in and say, allow users to call the application tool only when the coverage amount is below 5 million, it has to know exactly what the syntax for coverage amount and the tool name is. So it's going to be pulling the schema.
So
So
it should
let's ask,
understand the schema, and it does a pull to understand what is part of the schema and what are the parameters that the tool needs to be able to make a successful tool call.
Yeah. So when your developer is actually setting up your agent to with tools on the gateway, they're going to be adding the schema. Now, when I go in and create my policies in my, let's say, show and tell, let's start adding policies. Now, I don't have to worry. I'm just going to select my resource as that gateway,
Mm-hmm.
which is my insurance underwriting gateway. Now I can just use text saying allow users to create applications only when coverage amount. Where do you want to cap it? I know I was aiming for 10 million as my application.
Yeah,
As the product manager, where are you going to cap it?
I would say I don't know. You pick a number, right? So
Okay, let's say 5 million. Maybe I was too ambitious with my 10 million. Let's say, okay, any application over 5 million, we don't want the agent to process this, right? So we can just add this as natural language text here.
I don't want the agents to process more than $1,000, but that's me.
So this is just creating an insurance application. So we don't have to worry too much, right? You
Yeah.
can still like approve it or deny it based on what you see. Now, you can see here that a policy has actually been generated for you. So let's start like digging into what this policy itself is. Um, you can see the word permit here. Now, I told you when a policy is evaluated, it explicitly takes two actions. Either it allows an interaction to happen or it denies. So that is what this is. So this can, if it's permit, it allows it to happen. If it is a forbid, it denies the tool, the agent tool interaction. The principle is basically who is you trying to call this tool through the agent. Now, this is going to be your OAuth identity. This
Mm-hmm.
is how identity is going to plug in. Your principal defines your who. The second one is your what. So essentially, what action is it trying to take, or what is this agent trying to do, right? So the action is it's trying to call this application tool, which is the target name on the gateway. And inside the target, it's trying to call this function called the create application. Now, you
Mm-hmm.
can see now why it is so important that it has the correct inline schema for the target on the gateway itself is because it needs to pull in this proper syntax for the policy to be valid. The resource is my the AR on of my gateway, which it just figures out because we've also attached the resource here. And now this is the interesting bit. These are the conditions we're going to attach to the policy. So we're essentially saying if the coverage amount when context dot input is 5 million, then we're allowing this. Now, essentially, we're only allowing it if the coverage amount is 5 million, or which is what we've actually expressed here. Allow users to create applications only when coverage amount is 5 million, right?
Mm-hmm.
But actually, this was a mistake, is less than 5 million, is what I want to say. Allow users to create applications only when coverage amount is less than 5 million. Now, the condition part, it has this context dot input. Now, this is important to discuss. The context is everything that is flowing on the input request to the gateway itself. You can see it has updated the condition now. So it says now when the context input, this is going to contain all the tool parameters. So from the context input, it parses out the coverage amount and checks that it's under 5 million. If it is, it's going to permit it. And if it is over 5 million, it'll be a deny action.
Mm-hmm.
There is an additional thing which we also do for you, which is actually performing a validity check of the Cedar itself. So given that this is an LLM behind the scenes that is auto-formalizing your instruction into a Cedar policy, we still run a lot of like Cedar checks for you because Cedar as a language is constructed on automated reasoning, which means we can start looking for overly expressive or overly permissive rules, which you might not want to add by mistake. So we're just trying to add in extra safeguards on the console experience where you don't by any through any mistake create something that can disrupt your production traffic or cause experience that you don't desire. What I mean is, let's say I have an policy saying allow all users to call all tools.
Mm-hmm.
This is a extremely permissive policy, right? So I'm basically just allowing everybody permission to do everything on this agent. Now, you can already see in this insurance application, this is not desirable.
Mm-hmm.
The end user should not be able to call the approval tool, right? Otherwise, they're going to
Correct.
create the application and approve it themselves. Um, Here you can see that we're flagging it as a allow all. So we tell you it's an overly permissive policy. It permits all actions for all principals, and you should confirm that unrestricted access is intended before applying this policy.
Mm-hmm.
Here you can see the action is a list of these various tool names. It's listed all of it, and it basically permits every
Now,
user
since
or
you brought
every
this up,
principal.
Bharati, is this going to be by default? Is it deny all by default, and then do we approve only? I mean, allow only what we need to allow? Is that how we are designing this?
Yeah, excellent question, right? So a policy engine is supposed to give you the maximum safety and security safeguards. So essentially, the moment you attach a policy engine to a gateway, the default behavior is a deny.
Mm-hmm.
So unless you explicitly allow things to happen, the agent is going to be blocked from accessing the outside world. Now, if we think back again to this vision of safety as a box, we draw a very tight box around your agent and say deny by default, and you need to explicitly start allowing interactions to happen through these policies.
Excellent.
Now, there is also the case where you actually say, okay, that is too complicated for me. My use case doesn't deserve that. All I want to do is actually have one policy for one particular tool. This is the only one I want to restrict, right?
Mm-hmm. Mm-hmm.
That is when you would attach policies like this, saying, I'm very, very sure I want to attach a permit all policy. I want to allow all users to do everything. Then you can also create an explicit deny and say, I've allowed everything to happen except I don't ever want this approval tool to be called by anybody except the right user, right? So
Right.
you can create that deny, and the deny is going to take precedence
Mm-hmm.
over a permit. So this way, you can still have exactly the right kind of policies you want, even though you don't want this deny by default behavior, right? Because deny will take a precedence.
Right.
Now, what's happening is when I create this policy, it's going to fail. That's because I want to prevent people working on console by mistake creating any of these policies.
Mm-hmm.
So there is actually a little validation mode here. Now, this is going to handle how these warnings will be taken care of when we start going into policy creation. If I'm in a strict mode, the moment I try to create this policy, it's going to fail.
Mm-hmm.
I have to explicitly change it to a permissive mode for it to be allowed. By doing these extra clicks on the console, I'm basically indicating I'm very sure I want this policy. It's not a mistake, right? The SDK behavior is a little different because the SDK is already different flows where you first trigger the generation and then you take that generation and create a policy out of it. You don't have this validation modes. You only have it on the console behavior to kind of protect you from any inadvertent.
Because you're writing
um,
the natural language text, and you don't want to accidentally to for any of these to flow through this policy.
yeah, absolutely. Although the natural language to Cedar policy creation, you can also do all of these through the SDKs.
So
You
we
can
have
also,
questions coming in the chat where people are asking, how do we test this, right? So I guess, yeah, we're going to show that in a second here as we go into the details.
let me just put it into permissive and
Mhm.
then say create a policy, and let's move on. Right now, we can create like multiple policies like this. It needn't just be a single statement. It can also be paragraphs, which you can add here with a consistent delimiter. The second step is, now you can see my policy is active. The second step is associating it with a gateway. Right now, it's still not associated with a gateway, which means it's not monitoring any traffic yet. So you can go in here, select any of the gateways. My example is my insurance gateway, and you will go into enforcement the moment you pick one of these modes. Now you have an emit logs only mode. This is your shadow mode. And then the second one is enable enforcement. Now, this is basically going to be live, right? So
Mhm.
it's
Mhm.
not just going to look at what traffic is coming in and just log a decision, which is what your shadow mode does. In the enable enforcement, it's actually actively going to block interactions and allow interactions which are authorized through the policies. The moment you pick one of these modes and say associate gateway, then it's active. Then it's basically live and your policy evaluation will start happening. Did that answer the question, Anil?
Yep.
Were
Yep.
there others
We
questions?
we we are getting some questions. I'm taking them in the chat, but yeah.
Yeah, let's actually, I'm eager to kind of jump into the agent itself and show you what is happening. So before that, right, let's see some of those policies I've already created for the insurance application. So we saw 3 tools. Just to remember, there was an application tool, a risk model tool, and an approval tool.
Mm-hmm.
And let's look at some of these policies I've created. Now, here I'm permitting users to call the application creation tool when the coverage amount is less than 5 million. This is exactly what we also tested from natural language to Cedar. So this is the first policy. The second policy I have is for the risk model tool. And basically what I'm trying to do is a condition on the identity itself, on my principal. My principal, the identity is going to flow through as the JWT token with which this user is authenticating themselves with their associated identity, which associated IDP, which is attached as your AgentCore identity on the gateway, right? Now this IDP is, or the JWT token is going to have a list of like claims about who this person is. You can add claims like a department name, and say a department name can be finance, or you could belong to an engineering department. Now, essentially what I'm saying is only if you're in the finance department are you allowed to call the risk model tool. Anybody outside the finance department should not be able to access the risk model tool. So that is what this policy is doing.
So
The
we're going
last
to
thing,
extract that from the JW token and then allow the policy to evaluate this particular invocation, right? So yeah.
policy is automatically doing that.
Mm.
You are going to just configure on the gateway, you would have configured identity. Now, in my case, I'm actually using Cognito as my inbound identity.
Okay.
And I'm going to get a bearer token for myself from Cognito and use that in my invocations to the gateway. Now, policy will be able to see this information about what is in my JWT token directly and evaluate it.
Cool.
Now, just to remember, we have 2 policies attached on this gateway. And now we can look into the agent itself. Now, let me restart this agent. It's a very simple strands agent, which is connected to the gateway, and it's pulling all the tools from the gateway. Now I'm saying run interactive agent. Now you can see what it's first doing is it's getting my access token from Cognito. And I'm also printing out for you what information I have on my IDP claim, which is I have a department name. Right now, I'm a user belonging to the engineering department. I have an employee level cost center. These don't really matter from the perspective of policy, right? But what is important is I'm in the engineering department. Now I'm also telling you, printing out what tools this agent basically has. And you can see the only tool it actually has available to it is the application tool. And the reason is, you can remember there were 3 tools, right? But the first thing is there is a deny by default principle in action. There were no policies explicitly permitting me to see or use the approval tool. So I'm not able to see it at all. The second one was the risk model tool, but the risk model tool can only be used by people who are in the finance department, and
Right.
I'm in the engineering department, so I can't see the tool either. So this is where policy is interacting. Policy is applying not just on the agent tool interactions, but also on the list tools API when the agent is trying to call the gateway and check what tools do I have for my purpose. So because I don't see it, I naturally can't even call this risk model tool. But let's try to create some applications. Let's say I want to create an application for 10 million. That was my initial desire, and I'm based in the US region. Now the agent is thinking and it understands it needs to call the application tool, but it's not able to call the tool due to a possible policy violation. And it says, please check access with your permissions and what else can I help you with? Now, this is text that I instructed my strands agent to say every time it runs into a policy violation. But basically, it's getting an error code back when it's trying to call that
You're
tool.
looking at the exception and then letting the agent respond back.
Yeah, absolutely. Now, let's just try to create maybe for 1 million. I gave up on my hopes for 10 million, still in the US region, and I'm trying to say an application for 1 million. So now it's able to call the tool. You can see my tool is just a simple Lambda function that's just replying to you saying, hey, I've created this application for you for this coverage amount with this particular ID. So it's able to successfully call the tool. So the policy's actively been checking what the coverage amount is and deciding whether to allow that interaction to happen or not. Now, there is another thing we want to check, which is also the policy we attached to the user identity itself, which is on the risk model tool, right? So for this purpose, let me actually switch my role from being in engineering to finance. I wish it was that easy. For the code purposes, it is. So let's say I want to update my department to finance. Now, you can just think of these as helper scripts, which are for the purpose of the demo, basically manipulating the Cognito claim by injecting this custom claims into it, which is my department name and so on. So it basically changed my Cognito claims to finance department. Now, when I restart my agent, you will see that I'm in the finance department. You can see it's extracting the custom claim and it understands I'm in the finance department. You can already see when I'm in the available tools, it's able to see this risk model tool. Let's invoke the risk model tool. And I believe it needs the API classification.
So you can find the sample to the code in the chat, and it's also in the description of the video, but that's something you can do as well.
Yeah, absolutely. All the samples are on GitHub AgentCore page. So you can find everything I'm showing you in the notebooks there for you to execute as well. We also have some workshops for you to go into full use cases and execute that if that's what you want to try. But you can see in this case that it's been able to actually invoke the risk model because I'm in the finance department. So it's basically calling this like helper Lambda and saying success, it's been able to give you my risk score and so on.
So we have some questions in the chat here, right? So when an agent obtains a list of tools, can the information be brought back to the user? I would like my user to be advised of the tools that the agent has access to, right? So
yeah, yeah, absolutely. I can even ask, let's say here I'm explicitly printing out from my strands agent what I can see, right? Let's say your user is actually not able to see this, but I can also as a user just ask what tools can I use, right? And the agent understands what question I'm asking and it tells you also. It tells you there's an application tool, these are the parameters you need to call it. There's a risk model tool, these are the parameters you need. So as long as the LLM driving the agent actually has this information, it's going to reply to you. It's going to try to be helpful and tell you what information it has.
Right. And we also have a question about A2A. Again, Darkoin is asking if this is supported in A2A mode, like if agent to agent communication is involved. So, does it include that, right? So
A2A is just a protocol, right? But the idea behind it is I understand you have agents performing some tasks, and then you have a different agent which is actually accessing this agent for information or interacting with it. Now you can actually attach this agent also as a target on your gateway,
right.
and then all of this comes into play again. So you can basically say, I have a research assistant agent. Don't call this research assistant in under these certain set of
So agent
conditions. Now you
becomes a
can
tool
absolutely
in
create a
behind the
policy for it.
gateway, right?
Yeah, yeah, exactly. So yeah, we've already seen now how to author policies, how to attach them to a gateway. We've created a small strands agent. We see how it interacts. policy enforces both on the list tools API as well as the interaction between the agent and tool itself. So we're able to control it with policies. With Cedar itself, we saw the deny by default behavior. Default deny takes precedence. Now, the one thing we still want to see is how does observability look like, right? We said it's integrated with CloudWatch logs. Now, what is happening here? Now, once you go into um, so gateways actually has, you want to turn on tracing and logging here. So on my insurance gateway, I've actually turned on tracing, and I'm also feeding all these logs to CloudWatch.
Mm-hmm.
So we can go into now CloudWatch, and when we go into the particular gateway, you will see all the traces as traffic coming into the gateway being captured here.
So as we get into this, Bharati, there's one question that's asked, and we touched on this as well. How can you run this in monitor mode, right? So is that something that we can show as well?
By monitor mode, do you mean you don't
Like
want to
instead of
enforce anything?
correct, right? So
You simply want to. So what you would do is when I'm attaching my policy engine to my gateway, here you can see this policy engine with these two policies are attached to the insurance gateway.
Mhm.
Right now it's in the enforce mode. But what I want to do is convert this into the shadow only mode.
Right,
So if you put this in the shadow mode, then it's
it's only going
basically
to emit
going to
logs.
only log things, but it won't take any action. It'll tell you that $10 million insurance application is denied, but it will not block that interaction. It'll simply log it for you.
Hmm. Hmm.
So you
Great,
can see here now it's in log only.
excellent.
So let's look into CloudWatch. We see 74 invocations over the multiple times I've run this demo and and tested it. Now, what is interesting to note is you will actually see all the policy decisions as well. So you will already see over time how many of my policy decisions were allowed, how many were denied. And remember that this is not just for a tool call, but also every time your agent is asking, hey, what tools do I have, right? Every time you spin up an agent, it's going to first query the gateway and check what tools do I have. So it also applies to this. And you can see which policies are applied, how many times it
Hmm.
allowed and denied. But another interesting thing we show you is actually the mismatches.
Yeah, I was going to ask you, right? So if the tools names are changing or the details of the tools are changing, right? So and then the agent has already, the policy engine has already obtained it, and if the developers are changing the tools, how does this work?
Yeah. So essentially, if your developers go in and change the tool names or the tool parameters, and probably you've not really kept track of what policies were attached to this and haven't updated them accordingly, we actually identify and track this for you and show you as mismatched policies. So we're also tracking tool drift. So let's say that insurance claims application actually changed and maybe the coverage amount has been reworded or it's taking in different parameters now, right? So we actually track this difference and actually show you that as mismatched policy. So you can set up CloudWatch alarms, for instance, and if there's any mismatched policy that fires up, say go in and look at what your tool parameters are and tool name is, and go in and evaluate if your policies are up to date.
Hmm.
So within the yeah, basically your gateway, all these traces are being captured. And let's just look into one trace that I dug into that list of 74 to already show you, right? So you can see that there are different events that happen. First, it's trying to call the gateway. Let's actually not see this for a moment. It tried to first, it's going to call the gateway and try to invoke a tool. Then the policy is basically allowing or denying that action. So there is an
Hmm.
authorization action happening. And then finally, once it's allowed, it's able to call that risk model tool itself. Now, if we look at this trace itself, you will see that it's been trying to call the risk model tool. Policy authorize. So under policy authorization, it's going to tell you what decision it took, which is
A
allow,
lot.
and
Mhm.
you will also see what the determining policy was. So
So if
you're
you want
able
to
to
debug it,
identify.
you're able to
Exactly.
identify.
So you're able to audit it. So if you say an action happened, or then you will also explicitly see what was the determining policy that allowed that action to happen. Maybe you want to go and update this, or maybe this was unintended, right? So
Right.
you're able to trace back every agent decision back to a rule you've incorporated. So this is how you're really controlling what the agent does.
And do you have a sample of one of the policies that is denied, one of the tool call actions that was denied?
Oh yeah, absolutely, Anil. So let's actually look at a deny.
Or I think we could take a look at that, but maybe since we're getting close to the end of the, there is a question here about guardrails as well. So we have guardrails, and we also have you know this policy engine, right? So can you tell our viewers what is the difference here between the guardrails and policy engine?
hmm So guardrails and very specifically also Bedrock guardrails is going
Mhm.
to help you control what the LLM or the agents can say. So it's basically your safeguard that is going to come between the user and the LLM. It's going to both protect the LLM from what bad queries can go in from the user to the LLM, but also protect any bad responses from your LLM going to your user, right? Now, policy is behind the scenes. It's going
Mhm.
to control what the agents can do. So it's going to control agents to tools, and this is the layer where it's intercepting and controlling.
Right.
So guardrails help you control what the agent can say, and policy helps you control what the agent can do.
Excellent. Yeah, that's great. And I know we're getting close to the end of the hour, Bharati. Now, do you have like any takeaways for our viewers as we get close to the end of the hour here?
Yeah, absolutely. Anil, thank you so much, first of all, for having me. It's been a blast walking through the use case and talking about how policy can help you build in safeguards to control what the agent can do. We have policy in Amazon Bedrock AgentCore. It's going to help you govern, audit, and trust your agents. So it's actively intercepting all the traffic flowing into AgentCore Gateway at the moment and governing them through these deterministic policies that you're creating. Now, it also has very low latency policy evaluation for real-time decision making. We also saw how it's deeply integrated with CloudWatch for you to have this complete audit trail and visibility into what your agent is doing in runtime. So yeah, with
So,
that,
so we've shown how to not only deploy your agents into production in the prior episodes, but in this one we focus more on the governance and enforcing controls. But before you put them in place, you can create your policies, look at this in monitor mode, and then once you feel comfortable, then you can put those enforcement actions in place, right? So this is from today's episode in diving deep into Agent Core, the policy in Agent Core. But come back again next week, and we'll have more coming up, in this same channel. Thank you again for joining the live stream today. We'll see you next time. Thanks, Bharati.
thanks everyone. Thanks, Anu.